When a refrigerant leak is determined but unable to be located using standard procedures as described in Bulletin SS46-11, use Bulletin SS46-12 as a guide through the next steps to isolate the inaccessible components. These components are typically the heat exchanger and the condenser loop or Yoder loop, as they are most often embedded inside the cabinet foamed insulation. With all refrigerant recovered, begin by cutting out the dryer and examining the inside for contamination. Cut the tubing ends of each inaccessible component. This demonstration focuses on the Yoder loop, but whether the Yoder loop or heat exchanger is isolated first may be determined by the circumstances of the service call. The process tube adapter kit is designed as a charging tool. It can be used to pressurize up to 170 psi. Connecting to the isolated component for pressurizing above 170 psi will require either brazing or lock ring if so equipped. To isolate the Yoder loop on this model, the steel tube is cut just above but as close to the lock ring connection as possible. This is the Yoder loop entry point. The dryer is cut out at the Yoder loop exit if not already removed previously. The Yoder can be pressurized up to the high side design or test pressure when an access port is added to one end and the other end is sealed. This can be accomplished either by brazing or lock ring. When brazing, use thermal paste to protect insulation. Cap off one opening of the Yoder loop by brazing a pinched sleeve to the end. A sleeve will limit the amount of Yoder tube removal if no leak is found and reconnection is required. Braze a process stub onto one end after removing the valve core. Cool and inspect all joints. Set up and leak test the nitrogen equipment as described in Tech Tools Bulletin TT46-07 and record the model-specific high side design or test pressure rating. Connect the high side hose hand valve to the process stub and close the high side hose valve at the process stub. Connect the center port hose to the nitrogen regulator. Make sure the regulator is adjusted completely out. Close the manifold low side valve, open the high side valve. With the center port valve open and high side hose valve still closed, crack open the nitrogen tank valve. Slowly add some pressure on the equipment and listen for leaks. If okay, increase the regulator to around 200 psi, but do not exceed the high side design or test pressure rating for the model being serviced. If there are no equipment leaks heard, slowly open the system access valve. Now listen for an obvious Yoder loop leak. If none are heard, slowly increase the regulator up to the high side design pressure, which in this case is 300 psi. Wait a moment for the pressure to stabilize. It won't take long for the Yoder to reach the set pressure. Close the tank valve to prevent accidental overpressurizing. The gauge should be stable unless there is a significant leak present. Close the center port valve and close the manifold gauge high side valve. Make note of the exact pressure reading on the high side gauge. Again, listen for an obvious Yoder loop leak. The Yoder loop is typically routed around the freezer compartment and to and from the machine compartment. It is important to ensure there are no leaks where the process stub and sleeve were added to the Yoder loop ends. Use an approved leak detection solution to confirm, then wipe the solution off completely. Periodically, check to see if the pressure is holding or not. If the pressure cannot be obtained or maintained for 15 minutes, a leak is confirmed. Attach a piece of paper with the district and service order number, model and serial number, and the current date clearly written on it. Take clear photos at the beginning and during the procedure that include the time of day to document what has been done and when, and what results are found. If it turns out to be a non-repairable situation, be prepared to share photos of the connections, equipment setup, and pressures at the start of the test and currently via your phone and TechCam when calling stack. Follow the steps in TT46-07 to safely shut down the nitrogen leak test procedure and prepare the nitrogen equipment for transport. Again, this video supports Bulletin SS46-12, which has the steps and illustrations to isolate the Yoder loop as well as the heat exchanger on single evaporator models. Details on isolation of more complicated dual evaporator models by the 4 major manufacturers can be found in any of the 4 bulletins in Tech Assist, SS46-17, 18, 19, and 20.